So today we have an interesting geometrical problem. We take a square and label its corner as A, B, C, D. On the corner A, we draw a circle of radius 1 unit, and on the corner B, we draw a circle of radius 6 units, and both of these circles are tangent to their adjacent sides. Now we draw a line segment from the point D that is tangent to this unit circle and intersect AB at point E. And now from the point C, we draw a line segment that is tangent to the circle of radius 6 units and intersect AB at point F. Now we draw a circle of radius 12 units that is tangent to the line segment CD, CF and DE. Now the question is to find the area of the square on the basis of radius of these three circles and the arrangement of this diagram. So this is Anmol Mishra, and now let us see the solution. How can we find the area of the square? So first of all, we will utilize the fact that all the contact points between the circle and the line segments were tangent points. Therefore, when we have drawn the radius, at the point of intersection, the angle is 90 degree because that all points were tangent points. Now look in this quadrilateral PANM. This particular quadrilateral over here is a square because angle M and angle N are 90 degree because of the tangent points. Angle A is 90 degree because it is the corner angle of the square, and angle P is 90 degree by angle sum property. Now PM and PN are equal because they are the radius of this circle, and it has a value 1 because it was a unit circle. Therefore the square over here has all the sides equal and has a value 1. Now the same thing can be done in the other quadrilateral, that is over here, that is QSRB. Again by angle sum property, this angle is 90 degree, this length and this length is equal and it has a value 6. Therefore a square has been formed over here with all of its side equals to 6. Okay, so here we have seen that these two bottom corner quadrilaterals are square and they have a side length 1 and 6. Now what we have to find is area of the biggest square, and area is ultimately dependent upon the side length. So let the side length of the square be a variable x. This much distance is equals to 6. Therefore the remaining distance is going to be equals to x minus 6. Now the same thing can be done on the other side. The complete distance is equals to x. This much distance is equals to 1. Therefore the remaining distance is going to be equals to x minus 1. Okay, now we will draw two line segments. One will join the point C and Q, and other will join the point D and P. So now we can clearly see that this triangle and this triangle are congruent because of the right angle hypotenuse side, and similarly over here this triangle and this triangle are congruent because of the right angle hypotenuse side. So now once two triangles are congruent, rest of the things between them become equal. Therefore the angle QCS equals to angle QCT, and let it be equals to a variable theta. Now the similar thing on the left side, these two angles are equal and let it be equals to a variable alpha. Now the other thing that we are going to equate between these congruent triangles are the side length. DM is having a length x minus 1, therefore DU would also have a length x minus 1. Similarly over here, CS is having a length x minus 6, therefore CT would also have a length x minus 6. Now all the required markings for these bottom triangles are done. Now let us mark something about this middle triangle. So first of all we will draw two line segments, one joining the point O to the point C and the other joining the point O to the point D. Now again we can see we have pair of congruent right angle triangles. This triangle and this triangle is congruent because of the right angle hypotenuse side. This triangle and this triangle is congruent again because of the right angle hypotenuse side. Therefore the rest of the things become equal. So this angle and this angle is equal, and let it be have a value beta. And similarly over here, this angle and this angle is equal, and let it be equals to a variable k. So finally we have marked all the required things in the diagram. Now let us proceed to the actual solution. So first of all we can see angle D is a 90 degree angle because it is the corner of the square, and here it is equals to 2 times alpha plus 2 times beta, and it would be equals to 90 degree. Now if we will divide both the sides by 2, we will get alpha plus beta equals to 45 degree. Now we can take tangent on both of these sides, therefore tangent of alpha plus beta equals to tangent of 45. Now tangent of alpha plus beta can be opened up using the trigonometric identity, and it would be equals to tan alpha plus tan beta divided by 1 minus tan alpha tan beta, and this thing is equals to tan 45, and it has a very nice value that is equals to 1. Now on the left hand side of this particular equation, we have trigonometric ratios. Now we can easily calculate their values. Look in this triangle D, PU. In this triangle, the angle D is angle alpha and angle U equals to 90 degree. UP is having a length equals to 1 and UD is having a length x minus 1. Now using this triangle, we can easily calculate the value of tan alpha, and it is going to be equals to 1 upon x minus 1 plus the value of tan beta. So look in this triangle DBO. It is a right angle triangle and it contains the angle beta. Therefore, the value of tan beta from this triangle is going to be equals to 12 upon dV upon 1 minus tangent of alpha tangent of beta. So 1 minus 1 upon x minus 1 into 12 upon dV, and this thing is equals to 1. Now you have to simplify this particular equation so as to get the value of dV in the terms of x. So when you will solve it, you will get dV equals to 12 times x upon x minus 2. So here we have got the length of dV, and now let us utilize this particular thing. So what we have currently got is the value of dV. Now these two triangles were congruent, therefore the length of dV equals to length of dx. Now the complete length from D to C was equals to side of the square, and it has a value x. Now dx is having a value 12 times x upon x minus 2, therefore x to C is going to have a length x minus 12 times x upon x minus 2. Now again we can see that these two triangles are congruent, therefore this much length is equals to this much length. Now let us do our final step. So again we can see angle C is equals to 90 degree, therefore 2 times theta plus 2 times k equals to 90 degree, and when we will divide both the sides by 2, we will get theta plus alpha equals to 45 degree. Now we can take tan on both of these sides, therefore tan of theta plus k equals to tan of 45 degree. Now tan of theta plus k can be opened up using the trigonometric identity, and it would be equals to tan of theta plus tan of k divided by 1 minus tan of theta tan of k, and this thing is equals to tan 45 that has a value 1. Now on the left hand side we have trigonometric ratios, and we can easily calculate their values from the right angle triangles present in this diagram. So look in this right angle triangle, it contains the angle theta. QT is having a length 6 and TC is having a length x minus 6. They both were equal because these two triangles are congruent. So from this triangle, the value of tan theta is going to be equals to 6 upon x minus 6 plus tangent of k. So we can get its value from this right angle triangle. It contains the angle k. Perpendicular is having a length 12 and base is equals to x, c, and it is equals to x minus 12 times x upon x minus 2. Therefore, from this right angle triangle, the value of tan k is going to be equals to 12 upon x minus 12 times x upon x minus 2 divided by 1 minus 6 upon x minus 6 into 12 upon x minus 12 times x upon x minus 2, and this thing is equals to 1. And when you will simplify this particular equation, you will get a simple quadratic equation, nothing harder will be there. You will get the value of x as equals to 32, and what we have to find is area of the square. Therefore area of the square equals to x square, and it would equals to 1024, and that's the answer that we were looking for.